Oh, well, what's this? Hmm, alrighty. Now let's see. It says particles in motion. Well, that's a lesson I can teach. Oh, well, hello there. Today I'm going to be telling you about. We are going to be talking about how particles move, what determines how much energy particles have, what happens to a liquid when kinetic energy changes, how do you how do particles in a gas behave compared to particles in a liquid, and what evidence do we have that particles in a solid move? Okay, let's get started. Okay, so first let's talk about what are particles. So particles are a small unit of matter, aka these things. These are particles, and these particles move around in any substance. For example, a glass of water. These particles will continue to move even if the water looks still. These particles often collide and bump into each other and in a way called random motion. Random motion is random movements in all directions at different speeds. This movement is, of course, caused by energy inside these particles. Everything needs energy to move. And movement comes from the energy that particles have, determined by temperature. I bet you think that this ball is rolling right now. Well, it is. And the reason why the ball is moving so fast and at a different speed is because it has particles which have energy. So when these particles move, the ball also will move with it. Remember, energy is the ability to cause change. So let's learn more about what determines energy in particles, which is temperature. saw we said that the added energy caused motion energy, and that is also known as kinetic energy. Saw in the example, the motion increased in the hot plate because we added energy to it. So that is also called kinetic energy, an increased motion. As the kinetic energy increased, the speed of the particles increased as well. And the faster the particles move, the more kinetic energy they have. And also, do you know how to determine or show how a particle is moving? Well, you can use these vibration lines. The more vibration lines each of these particles have, the faster they are moving. We have three vibration lines on each one. These are the vibration lines right there. And these vibrations are how we show movement in particles. Now let's move on to the next lesson called what happens when to a liquid when kinetic energy changes. We we know that as the temperature of a material increases, its particles move faster or have a faster motion. And when they have a faster motion, they would collide with each other way more. Collide is to bump or move into each other and come together, but they don't mix. And when they push against each other, they are spread farther and farther apart, thus creating expansion. We call that thermal expansion. However, the opposite can occur. The energy and temperature can decrease, and kinetic energy can be lost, thus leading for the volume to decrease, or we call that thermal contraction. The property of thermal expansion and contraction can be used to measure temperature. Temperature is also the measure of kinetic energy. The temperature of a substance depends on how much kinetic energy the material has. The particles that make up this material is the determination on how much kinetic energy that you can feel with temperature. To compare temperature, you need to use a temperature scale. A scale uses two fixed points and divides the space between the 2 points evenly. The Celsius scale is created with fixed points of 0 degrees Celsius. When the water freezes and uh, 100 degrees Celsius when water boils. Other scales include Fahrenheit and Kelvin. The Celsius scale is used by scientists worldwide. Scientists also use the Kelvin scale. The Kelvin scale was invented to predict what temperature particles would stop all motion. This temperature is known as absolute zero K. If a material reaches 0 K, the particles in that material will not be moving and will no longer have kinetic energy. Scientists have not been able to cool any material to 0 K. Okay, good. Next lesson. How do particles in a gas behave compared to particles in a liquid? Well, gas particles move in straight lines until they collide with something, like another gas particle. These collisions change the speed and direction of the particle's movements. If you ever wondered why you could smell a scent from the kitchen, but you were nowhere near it, it's because gas particles move, and they move in that same straight line until they collide. So imagine this. This probably happens to you, right? Well, that's the same thing as what we're talking about. This is an illustration of what we mean. The gas had moved all the way from the kitchen right to your room for you to smell. Gas particles can move at high speeds and have high amounts of kinetic energy. Gases can expand and contract. Just like diffusing means for gas moves from an area of low concentration to high concentration. Just like diffusing in a beaker of water, being able to smell a scent over a distance is evidence of particles moving. Okay, this is the second last topic we're going to talk about. What evidence is there that particles in a solid move? Let's find out. Solids are known as having a definite shape. A definite shape, not like liquid and gas. They don't have particles that move or collide with each other. They stay put and vibrate if any movement occurs. The only movement the solid gets is the vibrations of kinetic energy. When kinetic energy is applied or added to the solid, it will vibrate and expand. When kinetic energy is lost, the solid will contract. Last lesson. The last lesson is, how does the total amount of a substance affect its energy? Energy and mass. So two substances have the same average kinetic energy by being the same temperature. When one substance has more particles, it has more kinetic energy. For example, there are 5 times as many water particles in 100 grams of water than in 20 grams of water. If the temperatures of the two water samples are the same, the sample with more mass will contain more total energy. The particles present, the more the particles present, the more total energy present in a substance. We reached the end of this episode. Goodbye.